galvanic cell or the voltaic cell. It is the second type. Now we are starting the second part of the chapter. That is electrogenetic cell. The electrogenetic cell, which is also known as galvanic cell, voltaic cell, or commercially it is known as a battery. Now it is a one where I can say that the chemical energy is converted into the electrical energy. So it is a cell in which the chemical energy is converted into electrical energy. Chemical energy is converted into electrical energy means here some reactions are continuously going on, and those reactions are spontaneous reaction. So here the reaction which takes place is spontaneous. So I can say that whenever a reaction takes place in a galvanic cell, those all reactions are spontaneous redox reaction. That means again here also there is a gain or loss of electron. Now let's talk about the example of the galvanic cell. With the help of that example, we'll learn about the whole galvanic cell. So here the example of the galvanic cell which we are going to do in this chapter is Daniell cell. Daniell cell, which is one of the example of the galvanic cell. Now, the Daniell cell, what are the requirements here I can say first? So for the Daniell cell, I can say the requirements are the first one is 2 half electrodes. Two half electrodes are required, out of which the one is the zinc electrode in a zinc sulfate solution in 1 molar zinc sulfate solution, and the second one is copper electrode in 1 molar copper sulfate solution. Then B, the next requirement is salt bridge. The salt bridge also required here. Now let's see how it works. That is a Daniell cell. So here we have 2 half cells. The first one, this is zinc electrode, which is placed in 1 molar zinc sulfate solution. That means here the electrolyte is 1 molar zinc sulfate. This is copper electrode, and here we have 1 molar copper sulfate solution which is placed inside. This is the salt bridge. This salt bridge also filled with some electrolytes which produces ions. and the end of a salt bridge is plugged with the glass wool or glass or the cotton. And this is the ammeter or galvanometer, which is used to measure the how much amount here the electricity is generated. So how much electricity is generated is measured with the help of ammeter or galvanometer is used. And okay, so this is the setup for the galvanic cell, I can say. So galvanic cell, where I said the chemical energy is converted into a electrical energy and the reaction is a spontaneous, means we are not doing anything, the reaction start by its own. Its own the reaction start and the some process continuously going on. Here we have zinc electrode, copper electrode, the salt bridge, ammeter, 1 molar zinc sulfate and 1 molar copper sulfate. As the apparatus is prepared, once the everything is set, the reaction will start by its own. Now there is a no battery is used, because here we are not passing electricity, but we are not applying electricity, but we are generating electricity. So there is a no like a battery, and since there is a no battery, so directly we cannot decide that which is a positive electrode and which is a negative electrode. I don't know which is an anode and I don't know which is a cathode. I know only that there is a two electrode, that is one is a zinc and the other is copper. Here I had used our two half electrode, sorry, the two half cells. It's not electrode, it's called two half cells, which is known as electrode. So first half cell, this is the first half cell and this is the second half cell, I can say. Each half cell is containing a electrode which is placed in the solution of the same metal electrode ions. Like a zinc is placed in the ions of same zinc. It may be zinc sulfate, maybe zinc chloride, maybe zinc iodide, it may be anything. But it should contain zinc ion, that is the same metal ion. Similarly, it should be a copper sulfate, it may be copper chloride or it may be copper iodide. Any ions I can consider, only the condition is that it should have the same metal ions. Okay, now let's talk about the salt bridge first. So what is salt bridge? The salt bridge is nothing but an inverted U-shaped glass tube, as it is in a diagram. This is an inverted U-shaped glass tube which is plugged with the cotton or wool. So, and then it is filled with some electrolyte. That electrolyte may be like a KCl or it may be KNO3 or maybe ammonium nitrate, anything. Here the electrolyte which you are using, like suppose if I am using a KCl, there are some requirement for the electrolyte. The requirement number one is that the electrolyte which is present inside the salt bridge, it should not take part in a chemical reaction. It should neither react with any of the electrode nor with any of the solution. After that, here the transport number of the K plus and that is the ions should be equal to each other. That means transport number, that means the mobility of the ions should be same. Both the ions should move with the same speed. Here NaCl is not generally used for as a electrolyte in a salt bridge. The reason because the potash transport number, that is the mobility of Na plus and Cl minus ion is not same. After that, here I can say that the salt bridge, this salt bridge, how it is formed, it's an inverted U-shaped glass tube. In this, we take a molten KCl. That molten KCl is added into this U-shaped glass. So molten KCl, but in addition to the molten KCl, that means this electrolyte plus we add some agar-agar gel. Agar-agar gel, it is added only to keep the whole thing into a semi-solid form, that is in a jelly form. Because when the molten KCl is kept, then it start cooling, and with the cooling, the KCl starts solidifying. And here, once the KCl gets solidified, then these K plus and Cl minus ion will not be free to move. So just to avoid the solidification, we add agar-agar gel, which keeps the KCl in a semi-solid form, so that the K plus and Cl minus ion can move. Okay. Here the first application of the salt bridge is that it maintains the contact between the zinc electrode, that is a electrolyte. There is a contact between the electrolyte. It maintains the contact between the electrolyte without mixing those electrolyte together. Here for mixing the electrogenesis process, that is for the generating electricity, there should be a contact between these two liquid. But once these two, but suppose if these two liquids are getting into contact with each other directly means it will be something like this. Suppose there is a one liquid in this container, there is another liquid in this container, and I'm mixing these two. This is the one method by which we can make the contact. But if both the liquids get into the contact with each other directly, then a liquid potential will generate it, and that due to that liquid potential, the process will stop, and that's so that the potential of the cell will goes on decreasing. So here the salt bridge makes a contact between both the liquid without bringing them directly into the contact with each other, so that the liquid potential does not arises. Here the two electrodes are connected with each other with the help of metal wire, and here the solutions are connected with each other with the help of salt bridge, I can say. Now let's see how it works, the working of this Daniell cell. Cell reaction. That means what reaction takes place. Here I'm saying that some chemical reaction takes place due to which electricity is generated. So what reaction is taking place? Here we have two electrodes. The one is a zinc and other is copper. Once, as I said, that if I'm keeping both the electrodes in a directly, means when the whole setup is prepared, once the whole setup is arranged, you will observe that the zinc electrode and copper electrode. From zinc and copper, I know that the SOP value of zinc is high. That means standard oxidation potential of zinc is high. So zinc undergoes oxidation, and if the zinc undergoes oxidation, then copper will start reducing. So here the zinc electrode which is taken start oxidizing. So the zinc electrode start oxidizing and produces zinc 2 plus ion plus 2 electron. And since zinc undergoes oxidation and the electrode where oxidation takes place, I can say that that electrode is called anode. So here the zinc electrode becomes anode. Again, it is an anode. It is decided by the reaction only. So here I can say that during a reaction, what happened? The zinc electrode which is containing this zinc electrode is containing a large number of zinc atoms. Suppose this is a zinc electrode. It is containing a large number of zinc atom. During a reaction, what happened? The one zinc atom come outside, it undergoes oxidation and get converted into zinc ion, and during oxidation it loses electron also. That zinc ion get mixed with the solution, but what about the electron? Electron get deposited or it remains on the electrode. So here the electron which is produced that get deposited on the electrode only, and the ions get dissolved into the solution. And since there is a large number of zinc atoms undergoing oxidation, so large number of electrons are evolved, and all these electrons get deposited on zinc, and that's why the zinc electrode carry negative charge. So here that's why we say that the anode carry negative charge. So the zinc, it is a electrode becomes anode, and this carry negative charge also. Now this negative charge will start through this metal wire, will transfer to the copper, and once this negative charge will come to the copper, that means the copper will also have a negativity, and due to which negative charge, here the copper ions, copper sulfate is there, that means there is a copper ion inside the solution. That copper ions will get attracted on this negative charge copper, so that copper will gain electron, it will attracted by this electrode, and copper will reaches to the electrode, will gain electron from the electrode and will form copper atom. That means which reaction? So I can say that reduction. And since at a copper reduction is taking place, that's why the copper is acting as a cathode. So copper electrode is a cathode now. Now in this case, once this copper ions comes to this gains electron, that means the electrode is losing electron, and electrode is losing electron, that means the electrode will have positive charge, and this positive charge is now cathode. In electrolytic cell, anode have a positive charge and cathode have a negative charge. But here in case of galvanic cell, that is electrogenetic cell, anode is a negative and the cathode is positive. This is the reaction which is taking place on the anode, and this is the reaction which is taking place on a cathode, that is the oxidation and reduction. And here I want the cell reaction. Cell reaction, that is the overall reaction, I can say. So to get the overall reaction, just add both the reaction taking place on anode and cathode. So here we will get a cell reaction after this. So cell reaction is, during addition, the electrons should get cancelled with each other. So here cancel electron, this electron cancelled, and so that we will have zinc plus copper 2 plus will give you gives zinc 2 plus copper electrode. So this is the cell reaction which is taking place in a Daniell cell. That is zinc plus copper 2 plus iron, which gives zinc 2 plus iron plus copper. Now, cell representation, the next thing. Cell representation. The cell we can whatever the thing or whatever thing I explained, it can be represented by a single line. So let's see the cell representation of this Daniell cell. So cell representation is zinc, it is in solid state, zinc 2 plus iron, which is a 1 molar, and then copper. This is the cell representation for the Daniell cell. Means by suppose if I don't know anything about the Daniell cell, but if I know the rules for the cell representation, then on the basis of this line I can elaborate everything. That means I can explain everything about the Daniell cell even if I don't know anything about it, just by looking to this cell representation part. This explain everything whatever we learn about the Daniell cell till now. So this is the cell representation. How we write, we will see afterward. That means once this is completed. Then after cell representation, the next is a cell potential. Cell potential will tells us that how much electricity is generated. Finally, we are generating here electricity only. That means that we are converting a chemical energy into potential energy. Sorry, chemical energy into electrical energy. So finally, how much electricity has been generated, I just wanted to know. So we measure it in terms of cell potential. This is called E naught. Naught means standard, so it is a standard cell potential. So E naught cell is equal to oxidation potential plus reduction potential. Here the oxidation is taking place on zinc and reduction is taking place on copper. The zinc oxidation potential in electrochemical series, it is given as 0.76, and copper reduction potential is given as 0.34. When it is added, we get finally 1.10 volt. That is E naught cell is equal to 1.10 volt. Means when the electricity is during a chemical reaction, 1.10 volt electricity is generated in this Daniell cell. Now let's see finally the conclusion part. That means what happens throughout the process. So finally what happens throughout the process, that is the conclusion, or I can say that observation. Say during a chemical reaction, I can say that electron is flowing from anode to cathode. Means here during the process zinc is losing electrons, so electron is produced here on the anode, that electron moves to the cathode. So I can say there is a flow of this is the flow of electron. The electron is moving from anode to cathode, and if there is a flow of electron, that means there will be a generation of the electricity will get generated, and that electricity always flow in opposite direction. That means the current will flow from here to here. This is the flow of current, that is from cathode to anode, that is always in a opposite direction. During the process, I can say that zinc electrode. So first conclusion, that is the first one. Here I can say that electron flow from anode to cathode through external circuit. And since electron flow from anode to cathode, therefore I can say this current will flow from cathode to anode. Okay. After this, during a process, what happens? The zinc electrode continuously getting converted into zinc ion and getting dissolved into the solution. That means I can say that with the time you will observe that the zinc electrode is continuously undergoing the destruction process. Continuously its amount goes on decreasing. It is getting destroying. So here I can say that the third one, the mass of zinc electrode decreases. The mass of zinc electrode decreases because the zinc electrodes are getting converted into zinc ion. That means I can say the zinc electrode which is produces a zinc ion in a solution, therefore the concentration of zinc ion increases. In a solution. And since the concentration of zinc ion increases inside the solution, then what happens due to this? Since the zinc ion increases, then ultimately I will say that in a solution the positivity will increase, the positive charge will increase, and once the positive charge increases, the reaction will stop. Because once the positive charge increases, the zinc will start producing the more positive ions. That means will stop producing the Zn2 plus ion. And if Zn2 plus ion is not produced, then the reaction will stop. That means here the solution for a reaction to take place continuously, the solution should be neutral in nature. There should be equal number of positive and negative ions. Initially there was like we were having a zinc sulfate, that means it was having an equal number of positive ions, that is a zinc ion and sulfate ion. But since some more number of zinc ion is produced from this, so due to which what is happening, the concentration of zinc ion continuously goes on increasing, and since the zinc ion continuously increases, therefore the positive ions will increase and the positivity will increase inside the solution. And as I said, if the positivity increases, the process will stop. So just to maintain the neutrality of the solution, what happens here, the KCl, this salt bridge is also having the electrolyte, that means it also contains the positive ions and negative ions. So once the zinc ion start increasing, it will produce negative ion from inside, so that the solution should remain neutral. So suppose if there is a one zinc ion is produced during the oxidation process, then to neutralize that zinc ion, how many chlorine ions will produce? And simply I will say that 2 chlorine ions will come from the salt bridge, as to nullify the charge present on this, that is a +2 charge. So to nullify that +2 charge, 2 minus charge is needed. So if there is a KCl, then salt bridge will produce Cl minus ions. Similarly, what happens here in the case of other container? The copper sulfate, it is present in the form of copper ions and sulfate ion, which was initially in equal number. But during a reduction, what happens? This copper ions is getting deposited on the electrode. And once the copper ion is getting deposited on the electrode, then positive ions get converted into neutral atom. That means I can say inside the solution, the positivity decreases, the positive ions decreases, due to which the negativity will increase. So to avoid that increase and to maintain the neutrality of the solution, what will happen? The salt bridge will produce positive ions, because here the positive ions decreases, so salt bridge will produce positive ions. So due to the loss of one copper ions, once Cu2 plus get deposited here, then similar to maintain that neutrality here, KCl, that salt bridge will produce 2 potassium ions. So there should be a production of K plus and Cl. There is a production of the K plus and Cl minus ion from the salt bridge into the solution to maintain the neutrality of the solution. This is the second application of the salt bridge. First application was that it maintained the contact between the two liquids without increasing the liquid-liquid junction potential, and the second is that it maintains the neutrality of the solution. Okay, after that, the fifth conclusion is that here I said that mass of zinc electrode decreases, but at the same time the copper ions is getting deposited on copper. That means I can say the mass of copper will goes on increasing. So the mass of copper increases. Electrode increases. Sixth, the copper electrode mass increases because copper ions is getting deposited. That means I can say that concentration of copper ions decreases in a solution. Then seventh point I can write about the E0 cell here, that is a cell potential. We got E0 cell is equal to, that is 1.10 volt. That means during electrogenesis, so much amount of electricity has been generated. So this is about the Daniell cell. Daniell cell, where we have the zinc electrode in a 1 molar zinc sulfate solution and copper electrode in a 1 molar copper sulfate solution. Cell reaction, cell representation, cell potential, and this is the conclusion which we have. So now let's see what happens when the same Daniel seal is connected to the some external source. External source means it is connected to the some external circuit, that is suppose here I am connecting it to some external circuit. Now when it is connected to some external circuit, so either it will act as a galvanic cell or it will act as a electrolytic cell, depending upon the potential of the potential of the cell and the potential of the external circuit. So there are the three possibilities I can say. The possibility number one, that is if the external circuit potential is less than 1.1 volt. What is 1.1? Then I can say 1.1 volt, it is a potential of the galvanic cell. If external cell potential is less than 1.1 volt, then what will happen? Then in this case, the cell will act as a normally like as it was acting, that is it will act as a galvanic cell only. If it is acting as a galvanic cell, that means the electron will flow from anode to cathode, and electricity will flow from cathode to anode. And there will be continuously the deterioration of the zinc electrode, that is the mass of zinc electrode will goes on decreasing while the mass of copper electrode will goes on increasing. So when the external potential is less than the 1.1 volt, that means the galvanic cell is going to be the dominant one. So whatever the things is happening inside the galvanic cell, the same thing will happen here also. But suppose the second possibility, if external source is, the potential of the external source is greater than 1.1 volt, then what will happen? If the external source potential is greater than 1.1 volt, then whole setup will get reversed. That means I can say, for example, suppose the battery is connected. If I am using a mobile battery, it is connected to the circuit, the external source. When it is connected to the external source, that is electrical socket, then the electricity inside that electrical socket is more than 1.1 volt electricity, or the more than the potential of that mobile battery. So in that case, the battery start acting as a electrolytic cell. Electrolytic cell, that is exactly the opposite thing will happen. In this case, the same reaction was if it is a external source is less than 1.1 volt, then reaction was same exactly it was as it was taking in case of galvanic cell, that is zinc plus copper 2 plus gives zinc 2 plus plus copper. This reaction was taking place in a galvanic cell, and here also the same reaction will take place. Now the second condition, when the external potential is more than 1.1 volt, then what will happen? It will start acting as an electrolytic cell. And once it start acting as an electrolytic cell, everything will get reversed. Everything will takes place in an opposite direction. That means the electron will start flowing cathode to anode, and if electron flow from cathode to anode, then electricity will flow in opposite direction. From anode to cathode. The opposite thing will happen again. The cathode will start, the deterioration of the cathode electrode will take place, while the zinc electrode mass will now start increasing, and the reaction which is taking place inside the container will also get reversed. That is a cell reaction. Now it will be zinc 2 plus and plus copper, which gives zinc 2 plus plus copper. Sorry, zinc plus copper 2 plus. That is a reaction get reverse. So if you want to suppose the reaction, during the reaction what happens, the zinc electrode slowly all the zinc electrode get converted, get dissolved into the solution. That is the zinc electrode get consumed, and the copper electrode suppose get increased. And if you want to reverse the process, then for reversing the process, just connect the whole Daniel cell to the external circuit, and inside the external circuit to which it is connected, the potential of the external circuit should be more than 1.1 volt. Then everything will get reversed. That means the extra copper which was get deposited here will start moving, will get dissolved into the solution, and the zinc ion from here will start depositing on the zinc. That means the things will get reversed. Then third possibility, if external potential is equal to 1.1 volt. If it is equal to 1.1 volt, then what will happen? It will neither act as a galvanic cell nor electrolytic cell. That means no cell, no reaction will take place, no flow of electron, no flow of electricity, and these things neither electricity nor electron is flowing because no reaction takes place. So if two different potentials are there, either the cell will act as a galvanic or voltaic only if there is a difference in the potential of the cell and the potential or the external circuit potential. If both are equal, then nothing will happen in the reaction in the electrolytic cell.